Okay, good morning. This is Professor David J. De Los Reyes. Our topic for this morning will be an interesting topic. This is similar to some example problems on short videos on short speed. On short speed, they were solving this problem by using the so-called laws of exponents. But for tonight, I will be giving you a solution that is the so-called advanced solution. I don't think this could be solved by the laws of exponents because the given numbers are not special numbers. It is a random number, so we could not use the so-called laws of exponent. So with a random number or a number designed to use laws of exponent, we can use this solution for tonight. That is the Newton's method of solution. So this is actually a variable, very flexible solution. Whether it is an abnormal number or a normal number, as long as we use this solution, we could solve the problem. Okay, I will check my camera. Okay, it's fine. Okay, we are almost done with the advanced mathematics. After this, I might be discussing the Maclaurin series of expansion. Okay, that will be our next topic, and that will be the finishing topic on advanced mathematics. So I will be discussing another subject matter. It could be algebra, maybe, or trigonometry. It's a complete course. Okay, let's proceed. Our lesson for this morning will be Advanced Mathematics, lesson number 38. And the title of the subject matter, it's application problem using Newton's method. So we will be solving a problem by using Newton's method, okay, to show the so-called importance of Newton's method. Okay, let's proceed. The given problem is 4 raised to x plus 5 raised to x equal to 50. As you notice it, some problems that came out on the short speed are actually well-designed numbers, so they could use the laws of exponent. But for tonight, those laws of exponent could not be used. So what we will be using will be the so-called Newton's method of approximation. The problem is asking for x. What will be the value of x? Okay, let's bring out the solution. This is the given equation. If we try to compress this one, function of x should be 4 to the x plus 5 to the x minus 50. We just place this on the left, and we call the total equation to be a function of x. Okay, let's try to compute for the first derivative of that given function of x. This is the given function of x. So f prime of x, meaning the first derivative of this, will be equal to natural log of 4 times 4 to the x. That will be the differential of this. And the differential of 5 to the x will be similar to this, except for the number. That will be natural log of 5 times 5 to the x. Or this is actually minus 0. Because the differential or derivative of 50 is a pure constant, and the derivative or differential will be 0. Or this is nothing. Okay, where did I get this one? It is one of the formulas under differential calculus. That is the derivative with respect to x of any constant raised to a variable u should be e to the u natural logarithm of a. So this one here is similar to this and similar to this. So it's a must that to pass advanced mathematics, you should know this differential or derivative coming from in differential calculus. That is the derivative with respect to x of a to the u will be e to the u natural logarithm of a. We applied this one in differentiating this, so this came out. Okay? Okay, trial number 1. We let x1 to be equal to 2. If we let x to be equal to 2, what will be the value of function of x? So I place it here. Function of x1 will be 4 square plus 5 square. I'm following this. Minus 50. 4 square is 16. 5 square is 25. 25 plus 16 will be 41. So 41 minus 50, there's a difference of negative 9. It is negative 9. Negative 9 is less than 0. So meaning, trial value number 1, what we assume is actually less than the required correct answer. Because the difference after taking the summation of this is negative 9. But just in case the summation will be 0, that will be the exact answer. But since this is negative 9, meaning this x1 here is less than the correct answer. That's why this is negative 9. Okay, we'll try to compute for f prime of x1. What will be the value of the first derivative if we substitute x to be equal to 2? So we will just follow this one. So this should be natural logarithm of 4, 4 square, natural logarithm of 5 times 5 square. Okay. We calculate this one by using our calculator. 4 square, you could visualize that one, that will be 16, right? This is multiplied by natural logarithm of 4, so we will use the open quantity times open quantity. Parenthesis. We are using lambda already. Okay? We display 4, but we need the natural log value of that one, so we will press natural logarithm of 4. We will close quantity. We took the natural logarithm of 4 already, but we haven't multiplied that 16. So if we press equal, it will now be 4 square times natural logarithm of 4. What comes out is 22.18. This is 22.18. Right? Same with the natural logarithm of 5 times this. Okay? 5 square is 25. So you could display 25 now. You try to multiply that by the natural logarithm of 5 times open quantity. We display 5. Take the natural logarithm. We close quantity. Actually, we are multiplying, but we haven't execute the multiplication already because we just close quantity. Upon pressing equal here, we multiplied already. So what comes out is 40.359, 40.23, 40.23. And if we try to take the sum of this, it is approximately 62.4159. We needed this one in the computation for the next trial value. Because in the next trial value, using Newton's method of approximation, this should be the equation. This is the general equation on how to take the value of the next trial value after the first one. Okay? This is the second, this is the first. So x2 is actually x1 minus fx1 over f prime of x1. That's Newton's method. That's why we call the solution here Newton's method of approximation. So substituting values, x1 is 2 minus open bracket. Function of x1 is negative 9. It's negative 9. F prime of x1 is 62.4519. A minus and a plus. The numerator is minus. The denominator is plus. Right? Fundamental laws of operations, a negative number over a positive number will be a negative number. A negative number times preceded by a negative number, it will now be plus. So meaning the ratio base should be added to 2. what comes out is 2.1442. You could check that one by using your calculator. It is 9 divided by 62.4159 equals, right? Since we know that the ratio of this should be added to this, so you just add 2 here. What comes out to is 2.14419, or same approximately 2.1442. Right? Okay, let's try to check if x2 now will be the correct value. You just get this value here, put it on that given function of x. So function of x2 will be 4 raised to 2.1442 plus 5 raised to 2.1442 minus 50. Okay. You could operate this one by using the calculator. Yeah, you try to use the x to the y or y to the x. So you just display for here y to the x, the exponent should be 2.1442. 2.1442 equals. The answer is 19.54. Okay. For this one, you just display 5 y to the x raised to 2.1442 press equals. That is 31.5305. So you add this one with this, what comes out is 51.07. You subtract 50 minus 50. 51.07 minus 50 is 1.07. It is greater than 0 by a value 1.07, meaning this value, second trial value 2.1442 is slightly higher than the correct answer. Okay, that's why I place it here, it's bigger. Okay, let's compute for f prime of x2. F prime of x2 meaning we will just get this value here, we put it on f prime of x. Okay, natural logarithm of 4, 4 raised to this, natural logarithm of 5, 5 raised to this, 27.889 plus 50.7464. What comes out is 77.8353. We needed this one in the computation of the third trial value. Okay, so trial number 3. Trial number 3 will be x3 will be equal to x2 minus f prime of x2 over f prime of x2. This is Newton's law of formula. Right? This is with the subscript 2, subscript 2, subscript 2, so this should be subscript 3. Okay, let's try to compute for x3. x3 now will be x2, which is 2.1442, minus open bracket. The value of fx2 is actually positive 1.07. Okay, f prime of x2 is positive 77.8353. A plus over a plus will be a plus, right? This overall side will be a plus, but this is preceded by negative sign. So meaning to say this ratio here should be subtracted from this. And if we try to take the ratio, okay, 1.07 divided by 77.8353. Hold on. 1.07 divided by 77.8353 equals. Okay? Since we know that we should subtract this ratio here, we put a negative sign over here. We add this one, plus 2.1442 equals. What comes out is 2.13044. 2.13044. Right? That's the third trial value. Okay, let's try to check if the value x3 is the correct value now. So function of x3, we'll get this value here, we put it here. we will pray that if we try to take the summation, the result will be 0. So 4 raised to 2.1344 plus 5 raised to 2.1344 minus 50. 4 raised to this is 19.1713. Use your calculator. 5 raised to this is 30.8399 minus 50. We take the summation of this, it is 50.01. We subtract 50, the difference is 0.01. Okay, if we are tired now, we could say that this 0.01, it's still not equal to 0, but it is almost 0. So I place it there, the difference is almost 0. So we could assume now that the correct answer will be 2.1344. Oh, this is the correct answer. Okay, that's it, guys. So meaning after 3 trials, we got the correct value already. We could check it. 4y to the x, 2.13044. Okay, that's the value, 19.1713 plus open quantity 5y to the x, 2.1344 close quantity, that is 30.8399. I will press equal here. I took the summation already. It is 50.01 minus 50. So the difference is very minute now. So we could say that the correct answer will be 2.1344. We are just getting the approximate value because we could not take the difference to be almost perfectly 0. That's why it is Newton's method of approximation. It is almost the same as the correct answer. Right? So the correct answer for this morning will be x equal to 2.1344. Meaning, 4 raised to 2.1344 plus 5 raised to 2.1344. Okay, if you take the summation, it is equal to 50. So the correct answer is x equal to 2.13044. Okay, so for those of you who are taking up advanced mathematics, this is for you guys. If you want to subscribe to my long video form channel, my channel is at youtube.com/@ProfDavidJ. And if you want to share it, please click share. Good morning from Los Angeles.